Okay, yesterday, what did we discuss yesterday in yesterday's class? Do you remember? What we discussed in yesterday's class?
Wheatstone bridge and sensitivity.
Yes, which one is that? Sensitivity. Okay. 1 minute. Yeah, okay. So in today's class, we'll be discussing about Kelvin's bridge. Do you have any doubt in that topic? Wheatstone bridge sensitivity analysis ಎರಡು ಗೊತ್ತಾಗಿದೆ ಅರ್ಥ ಆಗಿದೆ derivations.
Yes, ma'am.
Okay, what is the final equation for sensitivity of bridge? Okay, what sensitivity of analysis defines? What it defines? It is nothing but the deflection per unit change in the per unit fractional change in the value of the resistance. So a small change in the deflection, for a small change in the value of the resistance, it should show the deflection. So that deflection should be sensed. That is what is for the purpose why we are going to do the sensitivity analysis. What is the reason for doing the sensitivity analysis? What are the reasons for doing sensitivity analysis? Idra nenne class alli elro? Yes. Why should we do sensitivity analysis? What is the reason for doing that?
To find the amount of deflection.
To find the amount of deflection. No, that is also one of the thing, but not to find the amount of deflection. That is to check the unbalance in the bridge. So to detect the unbalance in the bridge. So how do we detect the unbalance in the bridge? For the balance condition, the galvanometer should go 0. If there is small unbalance in the bridge, means what happens? It should deflect. The galvanometer should not show 0, so that it will deflect from 0. That small change also should be sensed by the bridge. So that is the reason why we are going to do sensitivity analysis. Okay. What is the balance condition for Wheatstone bridge?
P by Q is equal to R by S.
Yes, P by Q is equal to R by S. And one more condition is P by P plus Q is equal to R by R plus S. You can write that also. And also current I1 and I2, I1 is equal to I3 and I2 is equal to I4. Okay. So these are some of the balance condition what you should understand. Okay, for detecting the range of the resistance using Wheatstone bridge. So Wheatstone bridge is used to measure which range of resistance? High, low, or medium?
Medium.
Medium range, yes. Okay, so now let's study about Kelvin's double bridge. Okay, Kelvin's bridge arrangement. So Kelvin bridge is used to measure the resistance of very small range. So through Wheatstone bridge, the main limitation of the Wheatstone bridge is that it cannot measure, like it will measure the resistance, but it won't show the appropriate value for the smaller range of the resistance. So in order to measure the smaller range of resistance, this Kelvin's bridge will work effectively. So Kelvin's range is particularly used to measure the smaller range of resistance. What is the range? Small range means what? Up to what resistance value? How do we classify the resistance range as low, medium, and high?
0 to 1 ohm, low resistance.
0 to 1 ohm is what?
Low resistance.
0 to 1 ohm is low resistance, and 1 to 100 kilo, it is nothing but medium range resistance, and above 100 kilo ohm or 0.1 mega, it is considered as high resistance. So Kelvin's bridge is used particularly to measure for 0 to 1 ohm. Okay, so now let us study the derivation part of Kelvin's double bridge. Okay, so how does Kelvin's bridge usually work? Okay, low resistance means where the low resistance usually exists. It exists in the contact. We call that as the contact leads. That is smaller, thin wires, thin strands, thin single strand wires. ಆ ಥರದ್ದೆಲ್ಲ ಇರುತ್ತಲ್ಲ, contact leads ಅಂತ ಕರಿತೀವಿ. So in that type of the wires, it will be having a very small resistance of the range 0 to 1 ohm. Okay, so let us study how this Kelvin's bridge is going. Kelvin's bridge is nothing but a slight modification of the Wheatstone bridge. Yes, can you hear me now?
Yes, ma'am.
Are you able to see the screen?
No, ma'am.
Okay, just present. ಯಾವಾಗ ಇಂಟ್ರಪ್ಟ್ ಆಯ್ತಿದು ಮಧ್ಯದಲ್ಲಿ ಹೊಟ್ಟೋಯ್ತಾ ಬಿಟ್ ಸ್ಟಾರ್ಟ್ ಕೆಲ್ವಿನ್ ಸ್ಟಾರ್ಟ್ ಆದ ತಕ್ಷಣ ಎಕ್ಸಿಟ್ ಯಾವಾಗ ಆಯ್ತಪ್ಪ ಯಾವ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಇಂದ
Ma'am, Kelvin Bridge used.
ಓಕೆ ಆ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಹೊಟ್ಟೋಯ್ತಾ ಡಿರವೇಶನ್ ಸ್ಟಾರ್ಟ್ ಆಗಷ್ಟು ಇರ್ಲೇ ಇಲ್ವಾಗಿದ್ರೆ
Yes, ma'am.
Okay, I'll explain again. Okay, see now I told you Kelvin's bridge is mainly used for what? For measurement of low range of the resistance. So this Kelvin's bridge, can you see the screen now?
Yes, ma'am.
Okay, Kelvin's bridge is nothing but the modification of the Wheatstone bridge. We are going to study Kelvin's bridge now, actually. But the derivation part you have to study for Kelvin's double bridge. That is different from this Kelvin's bridge. Okay. But before going to the Kelvin's double bridge, you should know how the Kelvin's bridge will operate first. Okay, what is the modification we have done in the Wheatstone bridge? Okay. So here, coming to this Kelvin's bridge arrangement, let us see. It also has same four resistance, four arm resistance, that is P, Q, R, and S. Okay. P, Q, R, and S are the arm resistance. Along with that, we are going to use another resistance that is called as lead resistance, small r. Small r, what you are seeing here, this is called as lead resistance. Okay. Along, see, the other things and all, it remains same, similar to that of your Wheatstone bridge only. ಓಕೆ ವೀಟ್ಸ್ಟೋನ್ ಬ್ರಿಡ್ಜ್ ಯಾವ ತರ ಇದೆ ಅದೇ ತರ ಅರೇಂಜ್ಮೆಂಟ್ ಇದೆ ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಆಡ್ ಒನ್ ಲೀಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಲಾಂಗ್ ವಿತ್ ದಿಸ್ ಓಕೆ lead resistance is added along with the other four resistance arms. Okay, that is PQRS jotege. Along with that, we are adding one more lead resistance in the circuit. Okay, this lead resistance connects the standard resistance, sorry, this unknown resistance R to the standard resistance? Yes. Okay, this lead resistance is used to connect the unknown resistance, what we have to measure, to the standard resistance. Yes. Okay, here you can see the galvanometer connections. In case of the Wheatstone bridge, ಏನಾಗ್ತಿತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಇಂದ ಬರೋದು ಈ ಸೆಂಟರ್ ಪಾಯಿಂಟ್ ಕನೆಕ್ಟ್ ಆಗ್ತಿತ್ತು Wheatstone bridge ಅಲ್ಲಿ ಅಲ್ವಾ. ಬಟ್ ಇಲ್ಲಿ ನಾವು we are using a small lead resistance. So lead resistance is a resistance which will be having a very low value, which we are going to measure now using Kelvin's bridge. Okay, so ಇಲ್ಲಿ galvanometer connection ಈಗ ಇಲ್ಲಿ ಬರ್ತಾ ಇರೋದು point of the galvanometer M, and one point will be going in this way. So there are two galvanometer connections made here. Okay, then when the galvanometer is connected to this point, you can see here ಈ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಇಂದ ಬರ್ತಾ ಇರುವಂತ ಕನೆಕ್ಷನ್ ಎಂ ಪಾಯಿಂಟ್ ಕನೆಕ್ಟ್ ಆಗಿದ್ರೆ, ಸಪೋಸ್ ದೆರ್ ವಿಲ್ ಬಿ ಟೂ ಕನೆಕ್ಷನ್ಸ್ ಬಟ್ ಟೂ ವಿಲ್ ನಾಟ್ ಬಿ ಕನೆಕ್ಟೆಡ್ simultaneously, so that is the reason why it will be shown in the dotted lines. So when the wire which is coming from the galvanometer, if it is connected to this point M, the lead resistance value whatever will be there here, okay, this will be added to the standard resistance. Yes. Okay, whatever value of the lead resistance that will come when we measure, that will be added along with the standard resistance. Yes. ಓಕೆನಾ. ಈ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಇಂದ ಬರುವಂತ ಕನೆಕ್ಷನ್ ಇಲ್ಲಿಂದ ಹೋಗಿ ಈ ತರ ಜಾಯಿನ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಈ ಲೀಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ ಮೆಜರ್ ಮಾಡ್ತಿರ್ತೀವಲ್ಲ ನಾವು, ಆ ವ್ಯಾಲ್ಯೂ ಇಟ್ ವಿಲ್ ಆಡ್ ಅಪ್ ವಿತ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಎಸ್. ಸಪೋಸ್ ಇಫ್ ದ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಕನೆಕ್ಷನ್ is added to the point N, if it is added to point N, then what happened, the lead resistance value will be added along with this unknown resistance R. Are you understanding? So in case of Kelvin's bridge, we are going to add an additional lead resistance along with the 4 resistance arm. Okay, lead resistance will be having a small value of value which we are going to measure using Kelvin's bridge. Okay, in case of this, as we are adding an additional lead resistance here, we don't know exactly where we have to connect the galvanometer. So this galvanometer connection is going to split up into 2 parts. So 2 points, it's going to connect at 2 different points. So when the galvanometer connection is made to this point M, we'll mark 2 points here, M and N ಅಂತ ಎರಡು ಕನೆಕ್ಷನ್ ಮಾಡಿರ್ತೀವಿ, ಪಾಯಿಂಟ್ಸ್ ಮಾರ್ಕ್ ಮಾಡಿರ್ತೀವಿ. ಎಮ್ ಕನೆಕ್ಟ್ ಆಗಿದ್ರೆ ಈ ಲೀಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ ಆರ್, ನಾವು ಆಡ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಲ್ಲ ಎಕ್ಸ್ಟ್ರಾ ಲೀಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ, ಅದ್ರದ್ದು ವ್ಯಾಲ್ಯೂ ಏನ್ ಬರ್ತಿರುತ್ತೆ ದಟ್ ವಿಲ್ ಬಿ ಆಡೆಡ್ ಅಲಾಂಗ್ ವಿತ್ ದಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಎಸ್. If the galvanometer is made, connection is made to the point N which is marked here, so whatever lead resistance value that we have considered now, that will be added along with the unknown resistance R. So in this way, the galvanometer construction will, the bridge construction will be made in case of Kelvin's bridge. Are you getting it?
Yes, ma'am.
Okay, so it will be added. So see, listen here. So when it is connected to point M, you can see here, when the galvanometer point is connected to point M, what happened? The resistance R will be added to the standard resistance, which resulting in the indication of very low resistance. It's going to indicate the standard resistance value will be having a very low value. Okay, but when it is connected to N point, what happened? What happens here? So the resistance R, the galvanometer will be connected to the point N. So what happened? The lead resistance value will be added along with the unknown resistance R, which will be resulting in the higher value. When it is connected here, N connect ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಅನ್ನೋನ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ನಮ್ಗೆ ಏನ್ ಬರ್ತಿರುತ್ತೆ ಅಲ್ಲ, ಇಟ್ ವಿಲ್ ಇಂಡಿಕೇಟ್ ಅ ವೆರಿ ಹೈ ಅನ್ನೋನ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ. ಬಟ್ ವೆನ್ ದ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದಿಸ್ ಪಾಯಿಂಟ್ ಎಂ, this standard resistance will indicate a very low value. See, that is what happened in this case. So suppose instead, same thing which is mentioned here, suppose if instead of using point M which gives low result and which gives N which gives high result, if you make the galvanometer connection to any point D, which will be marked by full line, I'll show in the figure 2. At point D, the resistance R will be divided into 2 parts, that is R1 and R2. See, instead of, see what happens, it won't show the proper value. If I connect the galvanometer to this point, standard resistance will be having a very low value. If I connect to this point, galvanometer, if it is connected to point N, it will indicate a very high value. It's not indicating the exact value, either low or high value we are getting. So instead of making the connection of the galvanometer either to M or N point, if you connect the galvanometer connection to another point D, what happened? This lead resistance value, whatever was there, which was indicating R, which was represented by R, it will be divided into two parts, that is R1 and R2. The lead resistance, contact resistance value will be equally divided into two parts, that is R1 and R2. That's what is mentioned here. So divided into two parts, R1 and R2, such that R1 by R2 will be equal to P by Q. R1 by R2, this R1 by R2 will be equal to P by Q. Okay. Then the presence of R, the resistance of the connecting leads, causes no error in the results. That is, so if I connect the galvanometer exactly at the point D, there will be no error in the reading. So we'll get the exact point because the galvanometer connected at the center point. If I connect it to point M or N, what happens? Either we'll get a low value or a high value. We won't get the exact reading. So instead of making the galvanometer connection to those 2 points, if I connect the galvanometer directly to D, this resistance, contact lead resistance value, it will be equally divided and it will not lead to any error in the results. So at balance condition, now as you know, R is equal to P by Q into S. That is nothing but P by Q is equal to R by S. Let us consider the balance condition for the derivation purpose. Now, let us consider R is added with the value R1 and S is added with the value R2. Because we are connecting the, see, look into the circuit, we are connecting this galvanometer to the center point D. Okay, so here if I add, so now the value of R will become R plus small r1. The arm resistance value of this particular arm, that is resistance which is connected to, connected between A and D, it will become R plus R1, whereas the resistance value in case of the arm CD, what was there initially S ಮಾತ್ರ ಇತ್ತು, ಈಗ ಈ lead resistance value ಅರ್ಧ divide ಆಗಿ add ಆಗಿದ್ದರಿಂದ it will become S plus R2. So that is what we have written here. At balance condition, first we are going to write what is the balance condition as we derived in case of the weak tone bridge. From the balance condition, we know that P by Q is equal to R by S, that is R is equal to S into P by Q. So in the place of R, we are replacing R plus R1 now because contact lead resistance value add agide. S ಜಾಗಕ್ಕೆ S plus R2 ಆಗುತ್ತೆ. So this equation can be written in this form. Okay. And also you know that now we have written here R1 by R2 is equal to P by Q. So, and then if R1 by R2 is equal to P by Q, then what happens? P by P plus Q will become equal to what? R1 by R plus 2. Itara baribodalva. See, if R1 by R2 is equal to P by Q, then P by P plus Q can be written as what? R1 by R1 plus R2. Can we write in this form? Hello?
Yes, ma'am.
You're getting right. That is from the balance equation what we have derived earlier. Okay, from that we are writing this form. So because you know that P by P plus Q is equal to R by R plus S antanu barkobodu navu. P by Q is equal to R by S is nothing but you can also write that in the form of P by P plus Q into R by R plus S. So instead of taking P by Q, I'll take P by P plus Q, which is same as this one. Okay. So if I take P by P plus Q, then this R1 by R2 can be written as R1 by R1 plus R2. Okay. Now replace this in this form, this equation. R1 by R2 na R1 by R1 plus R2 bariri. P by Q na P by P plus Q ta replace ಮಾಡಿ. Okay. Then start doing the simplification part. That is nothing but cross multiplication. And then simplifying. R1 plus R2 into P ಆಗುತ್ತೆ. R1 into P plus Q ಆಗುತ್ತೆ. ಈ ತರ cross multiply these two. Sorry. ಈ ಎರಡು ವ್ಯಾಲ್ಯೂ ಮಾಡ್ತೀರಾ ಅಂಡ್ ಇದು ಎರಡನ್ನು ಮಾಡ್ತೀರಾ. Okay, cross multiply ಮಾಡಿ you will get in this form. So R1 plus R2 is nothing but what? Look at the circuit. ಈ R ಅನ್ನೇ ನಾವು R1 R2 ಅಂತ ಡಿವೈಡ್ ಮಾಡಿರೋದು. This whole value of the resistance of the contact lead is what? It is R. This R we have divided into R1 and R2. So R1 plus R2 will give us what? R. So ಇಲ್ಲಿ R1 plus R2 ಏನು ಬಂದಿದೆ ಈ ಜಾಗದಲ್ಲಿ we are replacing it by R. So this equation now it will become R1 is equal to P into R by P plus Q. Yes. Next, again from this equation here, considering from equation 2, now replace the value of R1, whatever you have got here. ಈಗ R1 ವ್ಯಾಲ್ಯೂ ಸಿಕ್ತಲ್ವಪ್ಪ, ಈ R1 ವ್ಯಾಲ್ಯೂ ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ನೀವು ವಿಲ್ ಗೆಟ್ R2. ದಿಸ್ ಇಸ್ ಅವರ್ ಈಕ್ವೇಶನ್ 2. ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದಾರೆ. ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ R1 ಪ್ಲಸ್ R2 ಜಾಗದಲ್ಲಿ ಅಲ್ಲಿ R ಹಾಕೊಂಡ್ಬಿಟ್ಟಿದ್ದಾರೆ ಡೈರೆಕ್ಟ್ಲಿ. ಸೊ ಅಲ್ಲಿ ನೀವು ರೀಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ R2. Okay, in this way, you're going to find out the values of R1 and R2. Are you understanding the derivation? Any doubt idya? These are all substitution. That's all. I'm not explaining that in detail. ನಿಮಗೆ ಮೇನ್ ಆಗಿ ಈಕ್ವೇಶನ್ ಬರ್ಕೊಳ್ಳೋದು ಗೊತ್ತಾಗಬೇಕು. ಈ ಪಾರ್ಟು ಬ್ಯಾಲೆನ್ಸ್ ಕಂಡೀಷನ್ ತಗೊಂಡು ಹೆಂಗ್ ಬರ್ಕೊಂಡ್ವಿ ಇದಕ್ಕೆ ಅಂತ, ಯಾವ್ಯಾವ್ದಕ್ಕೆ ಏನೇನು ರೀಪ್ಲೇಸ್ ಮಾಡ್ಬೇಕಂತ ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. ಓಕೆ, ದಟ್ ಈಸ್ ಆಲ್ ಫ್ರಮ್ ದಿ ಪ್ರೀವಿಯಸ್ ಡಿರೈವೇಶನ್ಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ಅರ್ಲಿಯರ್ ವಿತ್ ದ ವೀಟ್ಸ್ಟೋನ್ ಬ್ರಿಡ್ಜ್. ಅಲ್ಲಿಂದಾನೆ ತಗೋತಾ ಇರೋದು ಈ ಬ್ಯಾಲೆನ್ಸ್ ಕಂಡೀಷನ್ ಎಲ್ಲ. ಈ ಜಾಗದಲ್ಲಿ ಜಸ್ಟ್ ಐ ಆಮ್ ರೀಪ್ಲೇಸಿಂಗ್ ನಾವು in keeping the circuit of Kelvin's bridge. Kelvin's bridge ಅಲ್ಲಿ ನಾವು addition to the Wheatstone bridge one contact lead resistance na add ಮಾಡಿದೀವಿ between R and S. Okay, that lead resistance as it was connected between R and S using 2 points M and N. ಅಲ್ಲಿ ನಾವು galvanometer na connect ಮಾಡಿದಾಗ ಏನಾಗ್ತಿತ್ತು ಅಂದ್ರೆ we were not getting exact values. When I connect the galvanometer to either N or point M, I was not getting the exact values. Okay, either I was getting a high resistance value or low resistance value. So instead of connecting this galvanometer to these 2 points, I thought of connecting the galvanometer to the center point. Let us assume that this D is a center point, that is the middle point of the in between point. Okay, so I connected the galvanometer at this particular point. So now when I connected the galvanometer to this particular point, this lead resistance whatever was added here, this was divided into two things, that is R1 and R2 ಅಂತ ಎರಡು ಪಾರ್ಟ್ ಆಗಿ ತಗೊಂಡಿದ್ದೀವಿ. So now when I add this R1 part to this particular R, the value of the resistance in this R will become capital R plus small r1, whereas for this resistance when I add it, it will become S plus R2. So ಈ ಬ್ಯಾಲೆನ್ಸ್ ಕಂಡೀಷನ್ ಜಾಗದಲ್ಲಿ R by R plus S, ಈ R ಜಾಗದಲ್ಲಿ R ನ R by R plus 1 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ, ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ದೀನಿ. ಈ ಜಾಗದಲ್ಲಿ S ನ S plus R2 ಅಂತ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ದೀನಿ. ಆಯ್ತಾ? ಆಮೇಲೆ ಫರ್ದರ್ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಅಂಡ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್. Okay, then we have considered another balance equation, that is R1 by R2 is equal to P by Q. But this can also be written as P by P plus Q, which is nothing. So if I consider P by P plus Q instead of P by Q, then I can write this R1 by R2 as also R1 by R1 plus 2. In this equation, whatever we have considered now here, ಈ ಜಾಗದಲ್ಲಿ we have replaced this equation. ಆಯ್ತಾ? P by P plus Q ಏನಿತ್ತಲ್ಲ ಆ ಜಾಗದಲ್ಲಿ we have replaced this equation. ಈ particular point ಅಲ್ಲಿ we have replaced R1 by R2 by R1 by R1 plus R2 ಇಂದ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ದೀವಿ. P by Q ನ P by P plus Q ಇಂದ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ದೀವಿ. ಆಮೇಲೆ just we have cross multiplied these things and obtained the value of R1. Similarly, keeping the same equation here, we have found out the value for R2 now. R2 ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ. ಇಲ್ಲಿ ನೋಡ್ಬೋದು ನೀವು, ಇದು ನಥಿಂಗ್ ಬಟ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿರೋದು. ಈ ಸ್ಟೆಪ್ನೇ ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ, ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದೀವಿ. ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ವಿ ಹ್ಯಾವ್ ಸ್ಪ್ಲಿಟೆಡ್ ದಿಸ್ ಈಕ್ವೇಷನ್ ಅಂಡ್ obtained the value for R2 here again. So R1 ಗೆ we got as PR by P plus Q. Here in R2 we got QR by P plus Q. Okay, after getting these two values of R1 and R2, let us substitute the value of R1 and R2 again in the balanced equation. Equation 1. ಈ ಜಾಗದಲ್ಲಿ ಇವಾಗ ನಮಗೆ R1 R2 values ಗೊತ್ತಾಯ್ತು. So now whatever equations we have derived for R1 and R2, substitute that in this particular equation 1. So when you substitute, you will get an equation like this. ಇದು ಈಕ್ವೇಶನ್ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀರಾ. R1 ಜಾಗದಲ್ಲಿ ಇಲ್ಲಿ ನೋಡ್ಬೋದು, ಇಲ್ಲಿ R plus R1 is equal to P by Q into S plus R2 ಇತ್ತು. R1 ಜಾಗದಲ್ಲಿ PR by P plus Q ರಿಪ್ಲೇಸ್ ಮಾಡಿದೀವಿ. R2 ಜಾಗದಲ್ಲಿ QR by P plus Q ರಿಪ್ಲೇಸ್ ಮಾಡಿದೀವಿ. Okay, then again simplifying these two by doing some cross multiplications and taking the LCM, we have done these things and we are going to obtain the balance equation finally. ಎಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ಸ್ ಆದ್ಮೇಲೆ we obtain the final equation, that is nothing but R is equal to S into P by P plus, sorry, P by Q. Okay, did you understand how we obtain this balance equation for Kelvin's bridge? ಇದರಲ್ಲಿ ಏನು ಅಂದ್ರೆ ಎಲ್ಲ ಡಿರೈವೇಷನ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ ನಿಮಗೆ ಸಿಮಿಲರ್ ಇರುತ್ತೆ. ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಜಸ್ಟ್ the substitution part, but only thing you should know is how the connections are made in the bridge. You should know the diagram of the bridge, to draw the bridge, and how this bridge is going to help in measuring the value of the resistance, either low or high resistance ನ ಯಾವ ತರ ಮೆಜರ್ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ದಟ್ ಯು ಶುಡ್ ನೋ, ಅಂಡ್ ಯು ಶುಡ್ ನೋ ದಿ ಬ್ಯಾಲೆನ್ಸ್ ಇಕ್ವೇಶನ್. ಎವ್ರಿಥಿಂಗ್ ನೋಡ್ಕೊಂಬಿಡಿ, ಫಸ್ಟ್ ಇಂದ ತಿಳ್ಕೊಳ್ಳಿ. ಯಾವುದೇ ಒಂದು ಇಕ್ವೇಶನ್ ಬ್ರಿಡ್ಜ್ ತಗೊಂಡ್ರು ನೀವು ಫಸ್ಟ್ ನಿಮಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಕಂಡೀಷನ್ ಗೊತ್ತಿರಬೇಕು. ಆ ಬ್ಯಾಲೆನ್ಸ್ ಕಂಡೀಷನ್ ನ ಹಾಕೊಂಡು ಜಸ್ಟ್ ದ ರಿಮೈನಿಂಗ್ ಥಿಂಗ್ಸ್ ಇಸ್ ಓನ್ಲಿ ದಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಪಾರ್ಟ್. ವಾಟ್ ಎವರ್ ವಿ ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ಡ್ ಇನ್ ದ ಬ್ರಿಡ್ಜ್, ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಎನಿ ಡೌಟ್ ಹಿಯರ್? ಡಿಡ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಪಾರ್ಟ್?
Yes, ma'am.
Yeah, but in the exam, when I ask you to derive the expression for Kelvin's bridge, you need not have to derive this part, whatever I explained now. This is for Kelvin's bridge only. Aita, but nimge main agi tilkobekagirodu ನೀವು Kelvin's double bridge working. Okay, so this is only the basic bridge of Kelvin's bridge. Okay, but there is some disadvantage in case of this Kelvin's bridge. So to overcome that Kelvin's bridge disadvantage, we are going to go for the Kelvin's double bridge solution. See, whatever we discussed now, that cannot be practically implemented. ಯಾಕೆ ಅಂದ್ರೆ ಸುಮ್ಮನೆ ನಾವು ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನ ಸೆಂಟರ್ ಪಾಯಿಂಟ್ ಅಂತ ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋತೀವಿ, ಮಿಡಲ್ ಪಾಯಿಂಟ್ ಅಂತ ಅಂದ್ಬಿಟ್ಟು ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ನಾವೇನೆ ವಿ ಮಾರ್ಕ್ ಸಮ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ವಿ ಕನ್ಸಿಡರ್ ದಟ್ ಇಸ್ ದ ಎಕ್ಸಾಕ್ಟ್ ಪಾಯಿಂಟ್, middle point, and we connected the galvanometer. But in practically, while doing the experiments or while measuring the resistance value, it is impossible to identify that particular exact point where to connect the galvanometer. So that is the disadvantage of this Kelvin's double bridge. ಈಗ ನಾವೇನ್ ಮಾಡಿದ್ವಿ, ಲೀಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ ಬಿಟ್ವೀನ್ ಆರ್ ಅಂಡ್ ಎಸ್. 2 ಪಾಯಿಂಟ್ಸ್ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ ಎಂ ಅಂಡ್ ಎನ್ ಅಂತ. ಸೊ ಏನಾಗ್ತಿತ್ತು, ಆ 2 ಪಾಯಿಂಟ್ಸ್ಗೂ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಐದರ್ ವಿ ವರ್ ಗೆಟಿಂಗ್ higher value or lower value. We were not getting exact value for finding out the resistance value. Okay, so ಏನಾಯ್ತು, ಅವಾಗ ನಾವೇನ್ ಮಾಡಿದ್ವಿ, what we did for the simplification purpose, we just identified one point as the middle point. Resistance, contact lead resistance ಅಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನ just we considered as the middle point, and we connected the galvanometer there and assume that this is the condition for the bridge to be balanced. That is, if I connect the galvanometer to this point, we'll get the exact value ಅಂತ ಅಂದ್ಬಿಟ್ಟು we did this derivation. We obtained the equation for finding out the value of unknown resistance. But while in doing the experiment practically, it is very difficult to identify that particular point exactly. ಇದೇ ಸೆಂಟರ್ ಪಾಯಿಂಟ್ ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ, ನೀವು ಇದೇ ಮಿಡಲ್ ಪಾಯಿಂಟ್ ಕನೆಕ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ಗೆ ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ. So that is the major disadvantage of this Kelvin's bridge. So to overcome that particular disadvantage, that is identification of the middle point, is the main disadvantage of this Kelvin's bridge. So in order to overcome that disadvantage, we just modified the Kelvin's bridge arrangement, and we did some modification, and we switched over to the Kelvin's double bridge arrangement. ಆಯ್ತಾ, ಯಾಕೆಂದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ ಪಾಯಿಂಟ್ ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಆಗ್ತಾ ಇರಲಿಲ್ಲ. ನಮ್ಗೆ theoretically we could have calculated easily, but practically exactly where we have to connect the galvanometer ಅನ್ನೋದೇ ಒಂದು ದೊಡ್ಡ ಮೇಜರ್ ಡ್ರಾಬ್ಯಾಕ್ ಆಗಿತ್ತು. So that is the thing. We just ignored Kelvin's bridge and we just switched over to the Kelvin's double bridge arrangement, where we can measure the value of the resistance exactly. So now let us study about Kelvin's double bridge arrangement. Okay, Kelvin's double bridge arrangement, you can look here. So here, this is the circuit diagram for the Kelvin's double bridge. Okay, Kelvin's double bridge ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, along with the 4 resistance arm whatever was there, P, Q, RS ಅಂತ 4 resistance arm ತಗೋತಾ ಇದ್ವಿ ನಾವು Wheatstone ಆಗಲಿ Kelvin's bridge ಅಲ್ಲಾಗಲಿ ಅಲ್ವಾ. ಅದ್ರ ಜೊತೆಗೆ another 2 ratio arms will be added with respect to Kelvin's bridge. That is called as ಈ capital letters ಅಲ್ಲಿ indicate ಮಾಡೋದನ್ನ outer ratio arms ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೇಕು ನೀವು. Okay, capital P and Q will denote outer ratio arms, and the small p and q denotes inner ratio arms. Along with this outer ratio arms, that is PQRS, capital letters ಅಲ್ಲಿ ಏನು indicate ಆಗಿದೆ, ಅದರ ಜೊತೆಗೆ we are going to consider another two ratio arms with this bridge arrangement, that is small p and q. Okay, this is the arrangement that is representing the Kelvin's double bridge. ಏನಕ್ಕೆ ಅಂದ್ರೆ ಇಲ್ಲಿ double bridge ಅಂತ ಯಾಕೆ ಕರಿತೀವಿ ಅಂದ್ರೆ there are another two ratio arms added along with the regular Kelvin's bridge. Okay, so let us study what are these things. So Kelvin's bridge, double bridge incorporates the idea of second set of ratio arms. Hence the name Kelvin's double bridge. Okay, so as it incorporates another two ratio arms, another two bridges along with the existing bridges, we call it as Kelvin's double bridge. And the use of the four terminal resistors for the low resistance arms. Okay, this is nothing but low resistance arms. Just explanations is given here. The first ratio arms is P and Q. That is capital P and Q indicates first ratio arms. Second set of ratio arms are denoted by small p and q. Okay, ಇದು ಬರ್ಕೋಬೇಕಾದ್ರೆ ಕೇರ್ಫುಲ್ ಆಗಿ ಬರ್ಕೋಬೇಕು. ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲೂ ಅಷ್ಟೇ ಕರೆಕ್ಟ್ ಆಗಿ ಓದ್ಕೋಬೇಕು. ಆಯ್ತಾ? ಔಟರ್ ರೇಷಿಯೋ ಆರ್ಮ್ಸ್ ಅಥವಾ ಫಸ್ಟ್ ಸೆಟ್ ಆಫ್ ರೇಷಿಯೋ ಆರ್ಮ್ಸ್ ಅಂತ ಕೊಟ್ಟಾಗೆಲ್ಲ ಅದನ್ನ ಕ್ಯಾಪಿಟಲ್ ಪಿ ಅಂಡ್ ಕ್ಯೂ, ಯಾಕಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡುವಾಗ ನೀವು ಮಿಸ್ಟೇಕ್ ಮಾಡ್ಕೊಂತೀರಾ. ಓಕೆ, ಫಸ್ಟ್ ಸೆಟ್ ಆಫ್ ರೇಷಿಯೋ ಆರ್ಮ್ಸ್ ಅಂದ ತಕ್ಷಣ ಕ್ಯಾಪಿಟಲ್ ಲೆಟರ್ಸ್ ಅಲ್ಲಿ ಇಂಡಿಕೇಟ್ ಮಾಡಬೇಕು ಪಿ ಅಂಡ್ ಕ್ಯೂ. that the value is given for the outer ratio arms anta. Small p and q will denote the ಅಲ್ಲಿ pq ಅಂತ ಏನು ಬರೆಯಲ್ಲ ಅವ್ರು ನಿಮಗೆ, ಜಸ್ಟ್ ಹೇಳ್ಬಿಡ್ತಾರೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಡೇಟಾ ಕೊಡ್ಬೇಕಾದ್ರೆ. outer ratio arms is given as so and so, so you should know it is p and q, capital p and q values ಅಂತ. inner set of ratio arms ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ you should understand the value given is for small p and q ಅಂತ. Okay, the second set of ratio arms is used to connect the galvanometer. So the outer ratio arms, inner ratio arms are connected. So the galvanometer is connected in between this outer ratio arms and the inner ratio arms. You can see, so for connecting this galvanometer between the, we have used another set of ratio arms, that is the second set of ratio arms, which is denoted by small letters, that is P and Q. Okay, to collect. So the main disadvantage was what? To identify the point to connect the galvanometer in case of Kelvin's bridge. So now we have made use of another set of ratio arms to identify the galvanometer connection, that is exactly to connect the galvanometer to the center position, which gives the accurate values. So for finding out the connecting the galvanometer at the exact position only, we are using another two set of ratio arms. Okay, so the galvanometer is connected between the two arms, that is outer ratio arms and inner ratio arms. See, that is what is written here. The second set of ratio arms P and Q is used to connect the galvanometer to point D at appropriate potential difference between point M and N to eliminate the effect of connecting leads. That is, whatever connecting leads we are going to add the lead resistance between the unknown resistance R and S to avoid the errors that will be incorporated with the lead resistance. That is, if you don't connect the lead resistance exactly, you're going to get some errors and the galvanometer will not show zero. That is, you're not going to get the exact balance condition. For that reason, this thing has been, like, we have selected another set of ratio arms, so the galvanometer will be connected at the appropriate position. So let us consider now. So the ratio of small p and q is made equal to capital P by Q here, always. Okay, while the measurement time and to keep the bridge balance, we'll consider the ratios of small p by q as equal to that of your capital P by Q. Now, converting this resistance P, Q and R, which is in the form of delta, to star. See here, you can see this bridge arrangement here. Star delta connections ಬಗ್ಗೆ ಓದಿದ್ದೀರಾ? Have you studied in networks?
Yes, ma'am.
Yes, you know, right, how to convert the delta connection to star connection. So initially, this is in the delta form. Okay, so now converting this delta connection to the star form, we'll get the circuit in this manner. If you observe, the circuit was initially like this. See, this PQ, okay, and R was connected in the delta form. So now convert this delta to star and replace the values. So what happens? The circuit will be in this form. Outer value we have kept as it is. The internal delta connection, whatever was there, that has been converted to star. Can you see this? It has changed to star connection here.
Yes, ma'am.
ಗೊತ್ತಾಗಿದೆ ಅಲ್ವಾ? ಕನೆಕ್ಷನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಬೇಕಾ ಹೆಂಗ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂತ? ಹೋಪ್ ಯು ನೋ ದಿ ಕನೆಕ್ಷನ್ಸ್, ರೈಟ್? ಡೆಲ್ಟಾ ಟು ಸ್ಟಾರ್ ಕನೆಕ್ಟ್ ಮಾಡೋದು ಗೊತ್ತಿದೆ ಅನ್ಕೋತೀನಿ, ರೈಟ್?
Yes, ma'am.
Okay, so this PQ, small PQ and R, which was in delta, that has been connected in star. Okay, so we get a circuit like this after doing the conversion. Okay, now let us obtain the equation keeping this bridge as the consideration. Okay, so for the bridge to be balanced, you know the condition, that is the galvanometer current IG has to be 0. Whatever current that is flowing through this galvanometer, it should be 0, and the potential difference has to be equal. That is whatever potential difference. So when the bridge to be balanced, obviously the potential difference between these 2 points will be 0. So hence, whatever potential difference that exists between VAB, that is VAB here, between these 2 points, it is equal to the potential difference existing between VAE. This one. Okay, as the potential, 1 second. ಇಲ್ಲಿ ಏನು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇರುತ್ತೆ? ಸೊ ಇಲ್ಲಿ ಏನು ಡಿಫರೆನ್ಸ್ ಬರ್ತಿರುತ್ತೆ? The same potential difference exists here as the galvanometer current will be 0. That is the potential difference between B and D 0 ತಗೊಂತೀವಿ. ಸೊ ಅವಾಗ ಇಲ್ಲಿ ಏನು potential difference exist ಆಗಿರುತ್ತೆ, the same thing will be coming here, considering that VAB is equal to VAE ಅಂತ ಇಟ್ಕೊಂಡು ಆ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. What is VAB now? What is VAB? This one. What is VAB? It is I1 into P. What is VAE? VAE ಹೇಳಿ. What is VAE? Tell me. VAB is what? I1 into P. You just drop across these things. Are you able to hear me? Connection cut ಆಗೋದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ, ಮಧ್ಯದಲ್ಲಿ ಮಾತಾಡಿ at least. Okay.
Yes, ma'am.
Fine. See, VAB is equal to I1 into P. What is VAE? Drop here across this branch. It is nothing but R plus
PR by P plus Q plus R into I2.
I2. Very good. R plus PR by P plus Q plus R into I2. Okay, substitute that here. So you'll get an equation, that is I1 P is equal to I2 into R plus PR plus P plus Q plus R. Similarly, the potential difference between VBC and VCE are same now. Look here. Whatever potential difference that exists here is equal to the potential difference between these 2 points, right? So VAB is equal to, VBC is equal to VCE. It will become VBC is equal to VCE. So VBC is what? I3 into Q. Similarly, VCE is Q. This is Q. QR by P plus Q plus R into, plus, yes plus PR, QR by P plus Q plus R into what? I4. So that is, let us keep that as equation 2. So equation 1 was I1 P is equal to R plus PR plus P plus Q plus R into I2. Whereas equation 2 will become I3 into Q is equal to I4 into S plus QR by P plus Q plus R. So let us consider equation 1 and 2. So also at the balance condition, you know that current I1 will be equal to I3 and I2 will be equal to I4, right? So I1 is given by what? So here, at balance condition, I1 is equal to I3 and I2 is equal to I4. So in this equation, in the place of I1, so now equation 2, here, this equation can be written as, what you can write here? I3 jagadali can replace I1, and in the place of I4, you can replace I4, right? Consider this equation. we know that at balance condition, currents I1 is equal to I3 and I2 is equal to I4. So you can replace I3 by I1 and I2 by I4 by I2, right? So substitute that, and this equation will be written like this. So now divide equation 1 by 3. Your equation 1 is this one. I1P is equal to I2 into R plus PR by P plus Q plus R. So divide this equation 1 by equation 3. This equation. Okay, left hand side by left hand side and right hand side by right hand side, you're going to divide and then do the substitution part. So I1 gets cancelled here and I2 gets cancelled. Okay, only thing that is remaining is P by Q is equal to this part. Already we have taken LCM and we have done the simplification. That is Rp plus Rq plus RR small r divided by P plus Q plus R plus PR here. This one. ಕೆಳಗಡೆ ಹಂಗೆ LCM ತಗೊಳ್ಳಿ. If you take the LCM, P plus Q plus R will be the LCM, small p plus Q plus R. Then cross multiply S with P plus Q plus R. Then plus QR by 1. QR into 1. So you'll get this equation. Start doing the simplification part until you get the balance condition. So here, just do the simplification. You can look here. So here, denominator gets cancelled here. As it is same in both the cases, P plus Q plus R cancel agate. Only numerator is remaining. So illi we have taken the R as the common factor here in this part. Illi S and common tegdidivi. We have written this equation in this form. Okay. Then further doing the simplification and all those things. So through we were just rotating the generator and we were getting the value of the resistance ಎಷ್ಟು ಅಂತ ಆ ಇನ್ಸುಲೇಷನ್ ಕೇಬಲ್ ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಈ ಮೆಗ್ಗರ್ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ. ಸೊ ಈ ಮೆಗ್ಗರ್ ಯಾವ ತರ ವರ್ಕ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಐ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಯು. ಲುಕ್ ಇನ್ ಟು ದಿಸ್ ಡಯಾಗ್ರಾಮ್. Okay, what are the main parts of this? Let us see. Okay, so here you can see here it consists of a DC hand driven generator. This is a hand driven DC generator. That is one of the major part of this, and it has a direct reading ohm meter. This is an ohm meter, direct reading ohm meter, which is going to show the value of the insulation cable resistance. Whatever we are going to measure, that value will be denoted on this thing scale. It's just a scale, ohm meter, which will read the value of the resistance. And this is a DC generator. Here you can see there are two coils. That is, one is potential coil. Sir, nimge watt meter explain ಮಾಡಿದಾರಲ್ವಾ? You have studied about watt meter, right? Yes, students. Watt meter ಅಲ್ಲಿ sir ನಿಮ್ಗೆ explain ಮಾಡಿದಾಗ I think he has told you about potential coil and current coil, right? ಕೇಳಿಸ್ತಾ ಇಲ್ವಾ? ಕೇಳಿಸ್ತಾ ಇಲ್ವೇನ್ರೋ?
Yes, ma'am.
He has told you about potential coil and current coil, right? Not heard about these things?
ಇಲ್ಲ ಮ್ಯಾಮ್ ಕೇಳಿದೆ ಏನು.
Okay, so potential coil, okay, it will be connected in parallel. Like watt meters ನಿಮಗೆ ತೋರಿಸಿದಾಗ ಗೊತ್ತಾಗುತ್ತೆ. Current coil will be connected in series with the meter actually. So there will be two coils here. That is, one is potential coil and one more is current coil. Here this potential coil and the current coil will be connected to the spindle. As you have seen that spindle, this is the spindle here what we are going to use here. Okay. ಸೇಮ್ ಇವಾಗ ನಾವು PMMC ಎಲ್ಲ ನೋಡಿದ್ವಿ ಅಲ್ವಾ, ಸ್ಪಿಂಡಲ್ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ, ಆ ಸ್ಪಿಂಡಲ್ಗೆ ಪಾಯಿಂಟರ್ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ. Okay, so which is fixed to the spindle, which is free to rotate about the vertical axis between the poles, north and south poles. So here also same principle like your PMMC, magnet, and this is the coil. Okay, this is a magnet and the coil. So to this coil, this is a coil. There it will be connected with two separate coils. That is potential coil and the voltage current coil. PC and CC and the potential coil and current coil. And the potential coil which will carry the voltage, current coil through which the current flows. Okay, these two coils will be connected to the spindle to which the pointer is connected. Okay, and the coil is placed in between this permanent magnet. Okay, so there are again these two coils will be connected to the leads. called as ligament. ಇಲ್ಲಿ ನಿಮ್ಗೆ ತೋರಿಸಿಲ್ಲ, it will be this one. ಕಾಣಿಸ್ತಾ ಇದೆಯಾ ಲಿಗಮೆಂಟ್ ಅಂತ? ಸೊ ಈ ಕಾಯಿಲ್ಸ್ನ ನಾವು ಇಲ್ಲಿಗೆ ನೀವು ನೋಡ್ತಾ ಇದ್ದೀರಲ್ಲ, ದಿಸ್ ಇಸ್ ಕನ್ಸಿಡರ್ as a potential and current coil. These coils are connected to the flexible ligaments, leads nothing but called as ligaments. Okay, then the current coil, again you can see here, the current coil is connected in series with the resistance R1, which is connected between the generator terminal and the supply link. You can see this resistor R1, it is connected in series with this current coil. Okay, current coil which is connected in series between the generator terminal and the supply link. Okay, this is the supply where we are going to connect. So it is connected in series with this particular link, generator terminal link. ಈ resistor ಏನು ನೀವು ನೋಡ್ತಾ ಇದ್ದೀರಾ, it is connected in series with this current coil. Okay, and the resistor R1, why we have to use this resistor here is, it is going to limit the current that is flowing through the current coil and controls the range of the instrument. That is, ನಿಮಗೆ ಹೇಳಿದ್ದೆ ನಾನು ನಿಮಗೆ ಇದು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್, ಏನಕ್ಕೆ ನಾವು ಕಾಯಿಲ್ ಇನ್ ಸೀರೀಸ್ ಆಗಿ ಒಂದು ರೆಸಿಸ್ಟರ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, ಫುಲ್ ಸ್ಕೇಲ್ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ಬೇಕಾಗುತ್ತೆ. ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಇಫ್ ಹ್ಯೂಜ್ ಅಮೌಂಟ್ ಆಫ್ ದಿ ಕರೆಂಟ್ ಫ್ಲೋಸ್ ಥ್ರೂ ದಿ coil, suddenly ಏನಾಗೋಗುತ್ತೆ ಅಂದ್ರೆ ಡಿಫ್ಲೆಕ್ಷನ್, ಪಾಯಿಂಟ್ ಆಫ್ ಡಿಫ್ಲೆಕ್ಷನ್, ಇಟ್ ಕಮ್ಸ್ ಔಟ್ ಆಫ್ ದಿ ಝೀರೋ. ಆಯ್ತಾ? ಟು ಕಂಟ್ರೋಲ್ ದಟ್, ಟು send the limited amount of the current through the coil, we are going to connect a resistor in series with the coils usually. Aita? This resistor is usually connected in series in order to limit the current that is flowing through the current coil or whatever coil we are going to connect. So ಅದರ ಅಕ್ರಾಸ್ ಏನು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅದನ್ನ ಲಿಮಿಟ್ ಮಾಡೋಕ್ಕೆ ಒಂದು ರೆಸಿಸ್ಟರ್ ಯಾವಾಗಲೂ ಸೀರೀಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ, ದಟ್ ಟು ಎಸ್ಪೆಷಲಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಕರೆಂಟ್ ಕಾಯಿಲ್. Okay, then the potential coil is connected in series with the compensating coil, this one. Okay, so this is also connected across the generator terminal. Okay, this resistor R2, this is connected in series with this potential coil and resistor R1, which limits the current flowing through the coil.
Ma'am, you're not audible.
Okay, so is it clear, the construction part? So the main are hand driven DC generator, ohm meter, that is which shows the reading of the resistance. Okay, and then the coil as well as the magnet. Okay, so so now how to check this measure is showing correct reading or not? Coming to the working principle, ಈಗ ಮೆಗ್ಗರ್ ಸುಮ್ಮನೆ ನಾನು ಇನ್ಸುಲೇಷನ್ ಕೇಬಲ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀನಿ, ಅದು ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕರೆಕ್ಟ್ ಆಗಿ ತೋರಿಸ್ತಾ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ ನಮ್ಗೆ ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ? So before connecting your cable whose resistance has to be measured, you have to do certain check on the megger. Okay, ಮೆಗ್ಗರ್ ಕರೆಕ್ಟ್ ಆಗಿ ಚೆಕ್ ಮಾಡ್ತಾ ಇದೆಯಾ, ಟೆಸ್ಟ್ ಆಗ್ತಿದೆಯಾ ಇಲ್ವಾ ಅಂತ ಹೆಂಗ್ ಚೆಕ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ, ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ಅಂದ್ರೆ, ಇನಿಷಿಯಲಿ you are going to keep these terminals open circuited. L and E terminals ಏನಿದೆಯಲ್ಲ ಇದ್ರ ಅಕ್ರಾಸ್ ಏನು ಕನೆಕ್ಟ್ ಮಾಡಬಾರ್ದು. You should not connect anything, you have to keep it open circuit. So what is the resistance in case of open circuit? What is the value of the resistance in case of open circuit?
Infinity.
Infinity. Okay, the resistance value so is infinity. So now you're going to keep these test terminals open circuited, and you are going to rotate this generator handle, that is hand driven DC generator ಏನಂದ್ರೆ ಒಂದು handle ಇರುತ್ತೆ, so you have to rotate it by using your hand, like manually you have to rotate it. Okay, you keep on rotating this. ಅವಾಗ ಏನಾಗುತ್ತೆ, as the circuit is kept open circuited, ಇಲ್ಲಿ ನೋಡಬಹುದು ನೀವು ಓಮ್ ಮೀಟರ್ ಮೇಲೆ, you can see it is marked as infinity and 0, and these are all the other things readings. Okay, one side ಅಲ್ಲಿ infinity mention ಆಗಿದೆ, ಇನ್ನೊಂದು side ಅಲ್ಲಿ 0 mention ಆಗಿದೆ. So when you keep this circuit, that ಮೆಗ್ಗರ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್, ಈ ಟರ್ಮಿನಲ್ಸ್ ಅಕ್ರಾಸ್ ಏನು ಕನೆಕ್ಟ್ ಮಾಡ್ದಲ್ಲ, ಇಫ್ ಯು ರೊಟೇಟ್ ದಿ ಜನರೇಟರ್ ಹ್ಯಾಂಡಲ್, ವಾಟ್ ಯು ಶುಡ್ ಗೆಟ್ infinity. The ohm meter should show you infinity, because when you start rotating this generator handle, what happens, due to which the current will flow through this potential coil. Okay, you have kept it open circuited now. Okay, the current starts flowing through the potential coil, and there will be no current flowing through the current coil. As you have kept it open circuit, no current flows through this current coil. You're going to rotate this generator handle. Okay, once you start keep rotating this generator handle, keeping these two terminals open circuited, what happens, large current flows through the potential coil here, and no current flows through the current coil. Okay, so the pointer will show deflection towards infinity. Open circuit ಆಗಿರೋದ್ರಿಂದ ನಿಮಗೆ infinity resistance is what? Resistance value is infinite. So you should get infinity. The pointer ಏನಾಗಬೇಕು ಅಂದ್ರೆ, initially middle position ಇರೋದು, it should move towards the infinity. This indicates that ಮೆಗರ್ is working properly. ಇದು ಒಂದು ಕಂಡೀಷನ್. ಒಂದು ಚೆಕ್ ಮಾಡ್ತೀರಾ, ಏನೋ ಫಸ್ಟ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಆಗಿ ಇಟ್ಕೊಂತೀರಾ, ಈ ಟರ್ಮಿನಲ್ ಅಕ್ರಾಸ್ ಏನು ಕನೆಕ್ಟ್ ಮಾಡಲ್ಲ, ಏನು ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಜನರೇಟರ್ ಹ್ಯಾಂಡಲ್ ರೋಟೇಟ್ ಮಾಡ್ತೀರಾ. ರೋಟೇಟ್ ಮಾಡಿದ ತಕ್ಷಣ ನಿಮ್ಗೆ ಏನಾಗಬೇಕು, ರೋಟೇಟ್ ಮಾಡಕ್ ಸ್ಟಾರ್ಟ್ ಆದ ತಕ್ಷಣ ಆಬ್ವಿಯಸ್ಲಿ large amount of the current flows through this potential coil, and no current flows through the current coil as it is open circuited. Open circuit, there is no current, right? Okay, so there is no current, so no current flows through this coil, and the pointer starts deflecting, and it will move towards infinity. This is case 1. Case 2 ಏನ್ ಮಾಡ್ಬೇಕು ನೀವು ಅಂದ್ರೆ, ಹಲೋ ಸರ್ ಹೇಳಿ ಸರ್, ಬಂದೆ 2 ನಿಮಿಷ. Okay, just I'll explain and go. Okay, we have a meeting now. Listen now. So say case 1 ಅದು. Case 2 ಏನು? Case 2 ಏನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ, ಈ 2 ಟರ್ಮಿನಲ್ ಇದೆಯಲ್ಲ, ಅರ್ತ್ ಈ ಮತ್ತೆ ಅರ್ತ್ ಟರ್ಮಿನಲ್ ಅಂಡ್ ಲೈನ್ ಟರ್ಮಿನಲ್ ಏನಿದೆ, ಈ 2 ಟರ್ಮಿನಲ್ ನ you are going to short circuit. You are going to do the short circuit. Okay, and then again you will start rotating the generator handle. ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಏನಾಗಬೇಕು, ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನು ನಿಮಗೆ ಎಷ್ಟಿರುತ್ತೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ 0. So when you start rotating the generator handle, now ಏನಾಗುತ್ತೆ, huge amount of current starts flowing through the, as it is short circuited, huge amount of current starts flowing through this current coil, and a very small amount of voltage will be, like current will be flowing towards this potential coil also. Okay, start rotating, and what happened, the pointer will start deflecting towards the 0 position. ಈ 2 ಕಂಡೀಷನ್ ನೀವು ಚೆಕ್ ಮಾಡಿದಾಗ, ಸೊ ಏನಂದ್ರೆ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಇಟ್ಟಾಗ ನಿಮಗೆ ಪಾಯಿಂಟರ್ ಇಟ್ ಶುಡ್ ಶೋ ಡಿಫ್ಲೆಕ್ಷನ್ ಟುವರ್ಡ್ಸ್ ಇನ್ಫಿನಿಟಿ, and when you short circuit these 2 terminals and start rotating this generator handle, you should get 0. Okay, so if these 2 conditions are satisfied, ಈ 2 ಕಂಡೀಷನ್ಸ್ ಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ವರ್ಕ್ ಆಗ್ತಿದೆ ನಿಮ್ಮ ಮೆಗ್ಗರು ಅಂದ್ರೆ, ನೆಕ್ಸ್ಟ್ ನೀವೇನು ರೆಸಿಸ್ಟೆನ್ಸ್ ಮೆಜರ್ ಮಾಡಬೇಕಿರುತ್ತೆ, ಆ ಕೇಬಲ್ ನ ಯು ಕ್ಯಾನ್ ಕನೆಕ್ಟ್ ಅಕ್ರಾಸ್ ದಿಸ್ ಅರ್ತ್ ಅಂಡ್ ಲೈನ್ ಟರ್ಮಿನಲ್. Okay, you bring the cable and you're going to connect it across the earth terminal and the line terminal. Then you start rotating this generator handle, so the required amount of the current will flow towards both potential coil and the current coil, and the pointer will start deflecting, and it will indicate whatever value of the resistance is there for that particular insulation cable. ಆಯ್ತಾ ಫಸ್ಟು ಮೆಗ್ಗರ್ ಸರಿಯಾಗಿ ವರ್ಕ್ ಆಗ್ತಾ ಇದೆಯಾ ಇಲ್ವಾ, ವೆದರ್ ದಿಸ್ ಮೆಗ್ಗರ್ ಇಸ್ ವರ್ಕಿಂಗ್ ಪ್ರಾಪರ್ಲಿ ಬಿಫೋರ್ ಟೆಸ್ಟಿಂಗ್ ಎನಿ ಆಫ್ ದಿ ಇನ್ಸುಲೇಷನ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕೇಬಲ್. ಫಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಚೆಕ್ ಫಾರ್ ದೀಸ್ ಟು ಕಂಡೀಷನ್ಸ್. ಒನ್ ಇಸ್ ಫಾರ್ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಕಂಡೀಷನ್ ಅಂಡ್ ಒನ್ ಫಾರ್ ದಿ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಕಂಡೀಷನ್. ಆ ಎರಡು ಕಂಡೀಷನ್ ಅಲ್ಲೂ ನಿಮಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಕರೆಕ್ಟ್ ಆಗಿ ತೋರಿಸ್ತಾ ಇದೆ ಅಂದ್ರೆ then you go for the cable. Then you go connect the cable across these two terminals, that is the earth terminal and the line terminal. Then you start rotating this hand driven DC generator. Once you start rotating, required amount of the current will flow through both potential and the current coil. Then the pointer will start showing the deflection. Okay, and it will come to rest at some position, some point, which is the value of the resistance, which is the value of that insulation cable. ಅರ್ಥ ಆಯ್ತಾ ಮೆಗ್ಗರ್ ವರ್ಕಿಂಗು?
Yes, ma'am.
Initially you have to explain about the construction and then you have to explain the working. Working ಅಲ್ಲಿ ಎರಡು ಕೇಸಸ್ ಫಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀರಾ, ಕೇಸ್ 1 and case 2. That is initially you are going to keep it open circuit and then rotate, and the pointer should show infinity. Okay, and then you are going to short circuit these two terminals, that is the earth terminal and the line terminal. Start rotating this generator handle, the pointer should show 0. Once these two conditions are satisfied, then you are going to connect the insulation cable whose resistance has to be measured across the terminals L and E, that is earth terminal and the line terminal. Then again start rotating the generator handle, the pointer will come to the rest at the point where, which is the value of the resistance. So this is how a megger will work. Okay, lab ಅಲ್ಲಿ if possible I'll show you the megger instrument ಇದೆ ನಮ್ಮ ಹತ್ರ, but I don't know how good it is. ಅದೊಂದ್ಸಲ ತೋರಿಸ್ತೀನಿ ಯಾವ್ದಾರು ಲ್ಯಾಬ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಫ್ರೀ ಆದಾಗ. ಓಕೆಪಾ, ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ಡಿ ಸಿ ಮೀಟರ್ಸ್ ಅಂಡ್ ಡಿ ಸಿ ಬ್ರಿಡ್ಜಸ್. ಒನ್ ಪಾರ್ಟ್ ಮುಗಿಸಿದೀವಿ ನಾವೀಗ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ. ಮೆಜರ್ಮೆಂಟ್ ಆಫ್ ಆರ್ ಎಲ್ ಸಿಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮೆಜರ್ಮೆಂಟ್ ನ ಆಫ್ ಆಲ್ ದ ರೇಂಜಸ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್, ದಟ್ ಇಸ್ ಲೋ ರೆಸಿಸ್ಟೆನ್ಸ್, ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್, ಮೀಡಿಯಂ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಮೆಜರ್ ಮಾಡೋದು ಯಾವ ತರ ಅಂತ ವಿ ಹ್ಯಾವ್ ಲರ್ನ್ ಟಿಲ್ ನೌ. ಎನಿ ಡೌಟ್ ಟಿಲ್ here? In the next class I will be starting with measurement of inductance and capacitance using different AC bridges. Is it clear?
Yes,
Yes, ma'am.
Can I stop the class? I take the attendance. Just a minute, screenshots ತಗೊಂತೀನಿ, ಏನು ಕರಿಯಕ್ಕೆ ಹೋಗಲ್ಲ. Why so less? ಇವತ್ತು ಬರೀ 48 members.